So this practical is Z9. Physical chemistry practical, the heat of neutralisation of an acid by a base. And this as a procedure, I'm going to play it here, is in two parts of procedure. Part 1, the water equivalence of apparatus, as we see here. And then part 2, heat of neutralisation of acid by base. So part 1 asks you to take, I'm just pausing here, a boiling tube, bottom clamp, and a beaker of water. So it asks you to pipette 50 ml of water into a boiling tube fitted with a thermometer, and suspends this in a beaker of warm water whose temperature is above 35 degrees C. So take some warm water from the tap with a thermometer and judge it to be about 35 degrees C, and clamp in here the boiling tube, and then obviously add in a volume of water. So pipetting 50 ml of water into here. So we're going to see our student as well, who's going to move through this with the pipette. So the student's going to pipette a volume of water. So using the pipette filler, wheel up the 50 ml of water to eye level towards the mark, and then transfer in to the flask the 50 ml of water. So we'll move this through. And then I'm going to pause it here. We're going to add a thermometer. So we're going to add the thermometer in place, and this time we're going to clamp the thermometer, we will hope, with some towel paper, so the tip of the thermometer, the bulb of the thermometer, does not hit the bottom of the boiling tube. So just moving this forward again very so slightly, the volume of water is in the beaker of a set temperature, clamped, and then the thermometer, the accurate graduated thermometer, is clamped in position. And note this, student, correctly so, to enable the thermometer to survive the process, would take some towel paper and wrap it around to guard the neck of the thermometer from shattering by clamping. So you're asked to take a series of results as shown, and at this point then asked here as well, after 5 to 10 minutes of observations, pour the contents of the boiling tube into a dewar flask, stir well and record the temperature for a further 5 to 10 minutes. So here we see the student here with the dewar flask. So over time these could possibly change at the University of Salford, but it's a dewar flask with a lid on, and you'll see here another thermometer is placed in position so the volume of solution can be poured into the flask. And we're going to see hopefully the student apply the solution inside and then mix together. So there's a little turning mixer here to allow agitation of the solution inside. So once you repeat part 1, the procedure for the water equivalence of the apparatus with water, you're then going to repeat again. So to dry the apparatus and to clamp a new boiling tube, and at this time to standardize into the dewar flask the 1 molar sodium hydroxide, and then to add into the flask the correct, as it says here, so pipette 50 ml of a standard 1 molar alkali into the dewar flask, and pipette 50 ml of a standard 1 molar strong acid into the boiling tube, and again take equivalent measurements and then mix together within this process. So this is a quite simple practical in terms of procedure. It's using this apparatus and this apparatus, but the issue here is about your treatment of data and how to take the data points, as you see as a graph plot, and feed it into these equations here to find the enthalpy of neutralization for a strong acid and a strong alkali. So this is quite sweet and short practical, and we'll leave it here for Z9, the heat of neutralization of an acid by a base. Thank you.